Till now, we have discussed three types of constraints, which were ordinal constraint, unique constraint, and primary constraint. And the fourth type of constraint is foreign key constraint, or we can say foreign constraint. So I'm just writing foreign, and this one is known as primary key. So starting with foreign key constraint. So it says foreign key is used to relate two tables. It means that if foreign key is applied, it means two tables are now related. Foreign key constraint is also used to restrict actions that would destroy links between tables. So here actions means the updation or deletion of records in a parent table. So foreign key also restrict these type of actions which are going to be performed on parent table. Uh, and the actions like deletion or updation of records. To understand foreign key, let's see its use with the help of below tables. And we have two tables with name customer underscore detail and customer underscore order table. So in customer underscore detail table, we have three attributes with name CID, customer name, and third one is address. And under customer underscore order table, we have again three attributes with name order ID, order name, and CID. Temporary data is also shown in this lab. So in customer underscore detail table, CID is primary key which is set as foreign key in customer underscore order table. So under customer underscore detail table, CID is a primary key attribute, or we can say primary key constraint is applied on CID attribute. And this CID attribute is used in customer underscore order table as a foreign key attribute. The value that is entered in CID, which is set as foreign key in customer underscore order table, must be present in customer underscore detail table where it is set as primary key. Now it says that the values which we are going to insert here, these values must be available under the parent table or under the CID attribute. Otherwise, it is not possible that you have to enter the values. Or we can say you cannot insert the values except these values, which are 101, 102, 103. If you are going to insert CID under customer underscore order table like CID 104, so it will generate error. So this prevent invalid data to be inserted into CID column of customer underscore order table. If you try to insert any incorrect data, DBMS will return error and will not allow you to insert the data. So you cannot insert the data except data which is already available under primary key attribute. So how it can be practically performed? So using foreign key constraint when creating a table. So there are two methods to apply the constraint, as we have discussed previously for each and every constraint, that you can apply the constraint during the creation of a table. I mean, you can apply the constraint after the creation of a table. So here we are going to apply the first method, means we are going to apply the constraint during the creation of a table. So before going to create customer underscore order table, and here foreign key is used, so we have to add the parent table in database. So I am going to create both the tables which are available here. I'm just erasing these. So first table is customer underscore detail table. So in which database we have to create these table? So I am going to create a new database with any name. For example, I am going to create a database with name my shop. Create database my shop. It's up to you that what name you are suggesting for database. So I'm just placing the database name as my shop. Select the query and execute. So database has been created under schemas. So here it is available. So before going to create a relation under this database, you have to enter in this database by using use command. So use my shop. Now we are in my shop database. Now you can create a table or multiple tables under this database. So I am going to create first table that is known as parent table. The name of parent table is customer underscore detail. So create table customer underscore detail, and the attributes under this table are CID. The data type is int and it is set as primary key attribute, or we can say we are applying the primary key constraint on this attribute in parent table. Primary key. The next attribute is customer name. This data type is varchar. We are setting size as 30 and I am applying normal constraint on this attribute. So normal, and the third attribute is with name address varchar and setting its size as 100. Just select the query and execute. Table has been created. Now I am going to create a second table, which is a child table in which we are going to create a foreign key or apply foreign key constraint. So the name of second table is customer underscore order. So create table customer underscore order, and the attributes in this table are order ID, which is set as integer, and a primary key constraint is also applied on this attribute, and the second attribute is with name order name. Its data type is varchar, size is 30. I am setting also normal constraint for this attribute, and the third attribute is CID. Its data type is int. Now keep one thing in mind, that we are going to apply foreign key on this attribute. Data type of this attribute must be same, which is set for CID in parent table. It's up to you that you are setting the attribute name same, or you can even set the attribute name different as well. Okay. Now applying foreign key on this attribute. So foreign key on CID. This CID attribute is the attribute of a child table. This one. So if the name is changed, you can use that name. References. Here references means where you are going to reference or where you are going to relate in other table. So the parent table name is customer underscore detail. Just copy and paste after references keyword. And in that table, the primary key attribute is CID. Sorry. Now this CID attribute is the attribute in a parent table attribute. Just close the parenthesis, terminator. Sorry. Select the query and click on execute button. So this child table has been created successfully. You can verify it by using describe command, that what is the behavior of this table. So describe, the name of table is customer underscore order. So here you can see that order ID is a primary key attribute and it will not accept null values. Why? Because we have set primary key on order ID attribute, and under CID it shows NUL under key column. NUL means multiple, means this attribute can accept duplicate values as well. And null, yes, it will also accept null values as well. So foreign key attribute can accept duplicate values, accept null values, but accept only those values which are available in parent table's primary key attribute, and it will not accept those values which are not available in parent keys in parent table's primary key attribute. So I hope you are understanding till now. So we have created practically. So we have applied foreign key during the creation of a table. Now the second method is using foreign key constraint after creating a table. So the example is alter table, then the name of table, which is customer underscore order, then add is a keyword, and foreign key again is a keyword, or we can say foreign key constraint. We are going to apply foreign key, and this CID attribute is available in child table. References to which table? Customer underscore detail, and this CID attribute is available in parent table. So you can apply by using this example after creation of a table. If you want to apply a foreign key constraint after the creation of a table. For multiple columns, here multiple columns means if you want to apply a foreign key constraint on table level, because in the beginning of this lab we had discussed this. Some constraints are known as column level constraint as well as table level constraints. So foreign key constraint is a type of constraint which can be applied on a column level constraint as well as table level constraint. So if you are going to apply foreign key constraint on a table level, it means on multiple columns combinedly. So on multiple columns combinedly, you can apply by using this way, like foreign key, and two attributes are like order underscore number comma book underscore ID. Reference is new order where order underscore number and book underscore ID are attributes available. So by using this method you can apply on a table level. So till now we have discussed non-null, unique, primary key and foreign key constraint in simple words. Now some things are related with foreign key attribute. So behavior of foreign key column on delete or update. As we have discussed two things, that foreign key also restrict the actions and these actions are updation or deletion of records from a parent table. For example, a foreign key is applied and it contains data. Parent table also contains data, and uh, uh, child table also contains data. I am describing over here. For example, this one is a parent table and this one is a child table. What happens if I am going to delete this record? Because this record is also referenced in a child table. Here CID 103 is available. If I am going to delete this record 103, that is Fabia, so what will happen on child table? So these can be described by three ways, which are explained over here. So when two tables are connected with foreign key and certain data in main table is deleted or updated, for which a record exists in child table, then we must have some mechanism to save the integrity of data in child table. So MySQL allows creating a table with cascade, set null, and restrict options. These are three options which are very important related with foreign key: cascade, set null, and restrict options. So I am explaining each and every one with practical. So cascade option deletes or updates the row from parent table containing primary keys and automatically delete or update matching rows in child table containing foreign keys. If cascade option is applied on delete as well as update, it means you can, if you can delete a record from child table, delete a record from parent table, then from child table also it will be deleted. If you update the record in parent table, then the record will automatically be updated in a child table. And the second option is restrict. Restrict option prevents the removal using delete or modification I using an update of row from parent table. If restrict option is used with foreign key, then on delete it will restrict that you cannot delete a record from parent table. If you want to update a record in parent table, again it will restrict that you cannot update a record in parent table. So mostly this restrict option is avoided because usually we want to update the records or delete the records from parent table. But if the data is very important and it is sure that data cannot be deleted or updated in future, then you can set restrict option on foreign key attribute. And the third option is set null. Set null option will delete or update the row from the parent table and set the foreign key column or columns in child table to null. So if set null is applied with foreign key and you want to delete a row from parent table, and that record, and if that record exists in a child table, then the value for that cell will be set as as null in child relation. For example, if we are going to set set null option, and we are going to delete this record, like a record whose CID is 103, then the value over here, it will be set as null. This record will be not deleted in child table, but only this cell will contain null value. If we apply set null during the creation of a foreign key. Okay. You can set null for delete as well as update. So we can set a null for delete as well as update. If you want to update a record in parent table, and then you can even set null in null for child. So if set null is used, you should not set non-null options to the columns of child table. This says that if you are going to set null option, then you cannot apply non-null constraint for those attributes. So here is practical the examples. So in first example, which is shown here, create table customer underscore order ID in primary key, order name varchar 60. Okay, I'm going to apply this in workbench. As we have created a customer underscore order table, so I'm going to delete this table and then applying again foreign key. So drop table customer underscore order. So table has been deleted successfully. Now I am going to implement first scenario, that is cascade. So here it is same. Now after applying foreign key, use keywords like on cascade, on update, cascade, on delete, cascade. This line shows that if you want to update a record in parent table, then the record in child table will automatically be updated. And if you want to delete a record in parent table, then the record from child table will automatically be deleted. So this is the first scenario, or we can say first option. And the second option is second scenario, or we can say second operation is on update, cascade, on delete, restrict. So here it means that on update, it allows that on update, if you are going to update a record in parent table, then the record in child table will automatically be updated. But if you want to delete a record from parent table, then it will restrict. It will restrict that you cannot delete a record from parent table, because this record exists in a child table. So this will not allow to delete a record from parent table if you set a restrict option. Okay. Even you can set a restrict option on update as well, like on update restrict. So now you cannot update or delete a record from parent table if that record exists in a child table. And the third scenario is, for example, on update, cascade, and on delete, set null. So here it says on update, if you are going to update a record in parent table, then the record will automatically be updated in child table. But if you are going to delete a record from parent table, then the value under child table will be set as null. Okay, so you can even set null on update as well. So for example, set null, sorry, on update instead of cascade set. Now if you want to delete or update a record in parent table, then the action in child table will be set as null value. So the real value existing in a child table will be removed and null value will be set. So I hope now this behavior or these behaviors are now clear to you. If you have any question related with these behaviors, you can even ask questions in live session. Okay. So till now we have completed 4 constraints. In the next one constraint, which is also very important constraint, which basically check the condition. So here the fifth constraint is check constraint. So starting with check constraint. Check constraint is used to restrict the value of a column between a range. So it will check that the value entered is within a range or is out of range. It performs check on the values before storing them into the database. It's like a condition, like in programming we have discussed if condition. So it's just like if condition. So before saving data into a column, it will check the condition and then it will, if the condition is true, then it will store the data in a database. So using check constraint means creating a table. Here it is written. So create table student, SID, SNAME and SH, three attributes are used, and check constraint is used on SID. So SID data type is int, non-null is set, and check constraint is also applied on this attribute. So check in parenthesis, we have written this that SID it must be greater than 0. It means when we insert records, you cannot insert SID in negative. So it must be greater than 0. So in this way you can apply check constraint. There can be more ways to apply check constraint, and I am also going to describe these ways. The above query will restrict the SID value to be greater than 0. It means that you cannot insert negative values under this column. Check constraint using in operator. So how check constraint can be applied by using in operator, like in this example, the check constraint is applied on country attribute. So for country attribute, data type is set as varchar. Normal constraint is also applied and check constraint is also applied. How we have applied check constraint? So we have written that check country must be in UK or USA. It means when user enters a record, the value for country must be in UK or USA, or otherwise this attribute will not accept any other value. Okay, so in this way you can apply the check constraint, or even we can apply check constraints like on gender. The gender must be in F or M, no any other character must be included. You can use check constraint with like or and operator, and also with case statement. So it's your homework that you have to work on like or and case statement, that how we can apply check constraint by using these keywords. Okay, so till now we have completed all the basic 5 constraints, which were not null constraint, unique constraint, primary key constraint, foreign key constraint, and check constraint. Sorry, and the spelling is CHECK. Okay. And the next one is auto increment and default. Default is not included in this lab because we have covered default in previous lab. In previous lab we have applied default property on a column, that if you want to insert a record and you don't want to insert a value for particular column, then the default value will be applied. So we have applied default in previous lab. So you can study from previous lab, that was lab number 7. So now I am going to discuss auto increment. Sorry. Auto increment is not a constraint as already described by me, but it is a column property. MySQL allows you to set auto increment to a column. Doing so, you will increase the value of that column by 1 automatically each time a new record is added. For example, like SID or serial number, if you want to say that this attribute must be automatically be incremented by 1 and value will automatically be added in a database, then you can say auto increment property as it is said over here. After the creation of a table, alter table customer, modify, by using modify keyword you can say so attribute is id and data type is int, and we have set a property auto increment. It means when we are going to insert records, you cannot add value for this attribute because this attribute will be automatically incremented by 1 and it will start from 1 and so on, 1 2 3 and so on. The above command will modify the id column of the customer table to an auto increment. So I hope that we have covered all the constraints and we have applied all the constraints practically and during the creation of a table. So here is exercise. Create table department with following attribute. These are the names of attribute and you have to apply primary key attribute on department number. Okay, so primary key constraint on department number, it means that at the end of attributes during the creation of a table you have to specify the primary key at the end of attributes during the creation of a table. And in second task, the name of relation is implied. These are the attributes and it is said that apply foreign key constraint on department number references the department table created in question number 1, which is this one, and primary key constraint on EMP number and department number. Now one thing is very important, that here it says that apply the primary key constraint on EMP number and department number. It means that you have to combinedly create a primary key by using EMP number and department number in implies relation. Okay. And the third task is alter table imply created in question number 2, which is this one, and apply the constraint check on ename attributes such that ename should always be inserted in capital letters. We have discussed these things in previous labs, so you had to perform this task. And task number 4 is alter table department created in question number 1 and apply constraint on dname such that dname should not be entered empty. So here you have to apply the constraint that dname must not be entered in empty. So we can even discuss in live session that what is the solution of this task if you have any confusion. And another task is alter table imply created in question number 2 and apply the constraint on SAL, that is sal means salary attribute such that no two attributes of the implies should be similar. It means the salary of two implies must not be same. In the task number 6 is alter table imply create an question number 2 and apply the constraint on department number attribute such that on update child value and on delete send null value. I think now it's very easy because I have cleared each and every a point related with the behavior of foreign key, which is cascade, restrict and set null. Okay, so I have discussed each and every point related with lab number 8, that was about constraints. Okay, one thing more, that how we can check the constraints which are applied on a table. So there is a query which is used to find out the names of constraints, which is a select query. Select constraint underscore name, constraint underscore name, comma constraint underscore type, comma table underscore name, from information underscore schema, dot table underscore constraints information underscore schema dot table underscore constraints, where table underscore name equal to user defined name. For example, I want to check the uh, constraints on customer underscore order. So constraint underscore name, constraint underscore type, and table underscore name. These are basically the attribute names. So till now there is no any constraint. Okay, डिटेल को हम चेक कर लेते हैं. Yes, there is one constraint which is a primary key constraint. Constraint name is primary, constraint type is primary key, and the table name is customer underscore detail. So by default the name of primary key is primary key. If you want to apply different names for constraint, then these names will be displayed over here. Okay, so this was just an additional information which I have provided to you, and this is very important query. If you want to see the names of constraints, you can use this example. Okay, so what kind of constraints will be displayed if you are using this query? So you can see the constraints: primary key constraint, foreign key constraint, check constraint, and unique constraint. check, normal or other things will not be shown. Only these four constraints will be shown if these four constraints are applied on columns. Okay. For example, if constraints are applied and we want to remove these constraints, then you can use alter command. So you can ask these questions during the live session. I will tell you how we can remove the constraints if we apply on a table. So I will discuss during the live session. Okay, so till now I think it is enough. So we are going to end this lecture. Allah Hafiz. If you have any question, you can ask in live session. Thank you.